Example 5. Write parametric equations from graphs. Use the parameter t equals x minus 1 to write the parametric equation that can represent y equals x squared plus 2. Then graph the equation indicating speed and orientation. So first, we're given this, and we want to find it is in terms of a parametric equation. So the first thing is we can get our x equation real easy. If I add 1 to both sides, I've already gotten that equation for what x would equal. X would equal t plus 1. Now all I have to get is my y equation. The way to do that is we're going to take what x equals here and we're going to substitute it in this equation. So I'm going to come and take my y equals, but instead of x, I'm going to replace it with t plus 1. And we're going to square that and add 2. Now this, we need a FOIL. Remember, that's not just t squared plus 1 squared. We need to do on this, I'm going to write it up above, t plus 1 times t plus 1. And so when I FOIL that out, what do I get? I'm going to get t squared. That is going, when we FOIL, remember you go here first, and then we multiply here. So we'd have plus a t. And then we multiply again, going inside times inside the I, which would be another t. That's really ugly. Let me try that again. Plus t. There we go. And finally, the last step in FOIL, last times last. So it would be 1 times 1, which is 1. So that would be the parentheses. Then we have this plus 2 on the outside. Now all we have to do is simplify. So when I simplify, I should have y equals t squared plus, it looks like 2t plus 3. So these would be my equations. Y equals t squared plus 2t plus 3. Here's what I can tell you about this. As I observe these, this is going to be a vertical parabola because this is the greater power. It's with y. And it should be moving to the right because x is, with the x equation, the t is positive. So as I look at this picture, it is moving to the right. It's a vertical parabola. This would make it seem that it would be shifted right 1. And this is off because this is not in vertex form. So you would think up 3, but let's just go to our picture in the graph and I'll show you where the origin is. You can see over here. Here's what's off. We're shifted right 1, and it is up 3 units, but it's not at the vertex of the graph. That's what's strange about it. This vertex is actually up 2 units. But this one, times 0, is not at the vertex. That's why I mentioned earlier that sometimes it's a little strange. In this case, it is a little strange that time equals 0 is not at the vertex. So it's moving to the right because x is positive. The reason it's a parabola going up is because the largest power is with the y. So you choose the largest power to see the shape, the smaller power, their smaller variable, to see the direction. Let's try this one. So here, it gives us this parameter and this equation. All right, so this time, to solve what x equals, we would divide both sides by 2. We can find out that x equals t over 2. Now I'm going to go and plug this in. So I come over here, and I would say y equals, but instead of x, we're going to put t over 2. And I'm going to square that, and then add 2. So when I square that, I should get y equals t squared over, remember, this is just top squared and bottom squared. So that'd be over 4. And then you have the plus 2 on the outside. So now we have our equations. We have x equals t over 2, and that y equals t squared over 4 plus 2. These are my parametric equations, and we can graph it. Again, this is the greatest power, so this will be a parabola. It's facing upward. It'll be a little bit wider because it's being divided here on the outside. So instead of being, it's a vertical shrink, so it's being compressed down. It'll be shifted up 2 for the time. So let's look at this. This time you can see it's the same, it looks like the same parabola because we came from the same y equals equation. So it's the same parabola, but what's different is time equals 0 this time is up 2 units. So previously, and it's not shifted left to right. Previously we were right 1 and up 3 for time equals 0 on the previous graph. This one, time equals 0 is here at what would seem to be the vertex of this graph. Let me show you again one more time in contrast. This one, the time was shifted right 1, up 3. Right 1, up 3, that's time equals 0. Either way, they both have the same parabola. It's in the same location, but just the time and the orientation, and the orientation is the same. It's moving to the right, because in both of these, the smaller power, which is x, is positive. If this were a negative, these arrows would be going this way. But it's just time equals 0 at a different time. Now, one more. Again, we have the same parabola, so this will be the same shape. This time, we can see when we solve for x, we're going to have a couple more things to do. First, I'm going to subtract the 2 over. So I'll do this down here. I'm going to have t minus 2, because that's what I was doing right here. I'm just going to run out of space, equals negative x over 2. Last step I'm going to do is, right now I'm dividing by negative 2. I'm going to multiply by negative 2 on both sides. So this time, that goes away with that. And so I'll have x equals negative 2t plus 4. Now I know what x equals. I plug it in to the other equation. And so I would have y equals, and here I'm going to have negative 2t plus 4. Color coordinate this. Squared plus 2. Again, we need to FOIL this. So if I went up above and had negative 2t plus 4 times negative 2t plus 4, when I FOIL this, I can see that I'm going to have first times first, which will be negative 2t times negative 2t is 4t squared. And then I will have negative 2t times positive 4, which is negative 8t. Here, another negative 8t. And then finally, 4 times 4 is 16. So I would have y equals 4t squared. Negative 18, another negative 8t is negative 16t plus 16 plus 2. So this equation, all we need to do is simplify those two. They'll become 18. We have 4t squared minus 16t plus 18. So again, this graph should look exactly the same as far as shape goes, but this time, the orientation, it should be going to the left, and times 0 would be right 4 up 18. So let's go to the picture, and you can't even see times 0 here. I was saying it would be right 4, so it'd be over here, and up 18 units. As you can see, it's making its way there, but it's not there yet. Notice the arrows are going to the left this time. It's because x is negative. So that's how parametric equations work. Now, you have one to try.